Hello AP Physics 1, it's Mr. Ng, here to do Giancoli Chapter 4, number 47 for you. So here it says a box is given a push so it slides across the floor. How far will it go? So it wants to find the displacement or the x, given that the coefficient of kinetic friction is 0.2 and the push imparts an initial speed of 4.0 meters per second. Okay, so let's do what we always do first, which is free body diagram. Free body diagram, here we go. Let's draw this box. Let's draw the floor. We obviously know that there's mg. Let's call it a negative mg because it's going down. We know that there's a normal force. And in this case, it's just going to be mg. Nothing's happening to the box. It's not being moved up or down or anything. There's no pulleys on it. We know that there's a F of friction. All right, it's going to be kinetic friction. I'm going to just call it Fk. K for kinetic friction. And oh, I bet some of you gave it a little F applied, but there's no such thing. You pushed it, right? A box was given a push a while ago. That force is gone. That force is not there anymore. It's sliding across, so there's no F of A in this free body diagram. That was probably one of the tricks, one of the things that you had to figure out to get this right. So now let's do a sum of forces. Part 2, sum of forces, like always. Sum of forces is equal to Fk is equal to mass times acceleration, right? That's it, right? There's no F of A, there's no minus F of A. Fk, or the force of friction, is equal to the kinetic friction coefficient times mg, and that is equal to ma. And because we want to know the distance, how far will it go, it gave us a speed. I'm thinking we need a kinematics equation. So the closest thing to kinematics is acceleration. So let's solve for acceleration. Thankfully, the masses cancel. So good, feels great, no mass. So we know that acceleration is equal to the friction coefficient times g. So this is equal to 0.20 times 9.8 meters per second squared. So let's punch that in. 9.8 times 0.2, and I got acceleration is 1.96 meters per second squared. Awesome. Part 1 kind of done. We have an acceleration. Now let's do VATX. V initial is, well, we know the V initial. It starts at 4 meters per second, 4.0 meters per second. V final, it freaking stopped. The acceleration is this thing. It's going to be a negative acceleration, so it's going to be negative 1.96 meters per second squared. And then time we don't really care about, but we do want x. For me, I feel like I want to do the Vf squared is equal to V initial squared plus 2ax, right? V final is going to be 0. This is going to be 4 squared plus 2 times negative 1.96 x. So let's just move that to the other side because it's got a negative anyways. So times 2. So 3.92 x is equal to 16. Divide both sides by x. I mean, not divide both sides by x. It's late at night, guys. Divide both sides by 3.92. Right, so here, clear it, 16 divided by 3.92. And I got x is equal to 4.08. I think it's 2 sig figs, right? So x is equal to 4.1 meters. So how did I solve this thing? Number one, I did a free body diagram. Biggest trick was knowing that there is no force applied. No, get out of here, force applied. You're not here. The push happened a while ago. Then I did a sum of forces. It was really easy because it was just the force of friction. I found A, good. And then using A, I put it into one of our old trusty kinematics equations, and then I solved for X. Seems pretty easy. Thank you very much for watching.